Okay, so let us move on to the next question. Might seem easy when you start, though it's not a difficult question, but certainly not easy, considering the way the question has been structured in terms of the language and the use of different variables. Okay, so A, B, C. So let's read the question. A is 40% less efficient than B. When you're saying that A is 40% less efficient than B, first you must know that efficiency is inversely proportional to time. So obviously, if you're taking more time to do a work, you're less efficient. If you take less time to do that given work, you're more efficient, right? So that's how it works. So it's inversely proportional. So when A is 40% less efficient than B, means if you consider their efficiencies, if B is doing 10 units a day, A is doing how much? 40% less. So he's able to do 6 units a day, right? Who can do the same work in 20% less time than C? So who here? It is B, correct? So if you take take into account the ratio of times taken by C and B, if C is taking 10 days, then B would take 8. And because efficiency and time are inversely proportional, you could say that then the ratio of their efficiencies would be 8 is to 10. Okay, so I hope this makes sense. Now, if efficiencies are in the ratio 8 is to 10, you could align all the three efficiencies, that of A, B, and C. And you could say efficiencies are in ratio CBA in ratio 8 is to 10 is to 6. Okay. So therefore, you've got the efficiencies aligned. So you've got 8 is to 10 is to 6. Can it be further reduced? Yes, it can. So you've got 4 is to 5 is to 3, which is the final efficiency ratio of A is to B is to C. So this is where typically most of the students who don't have a command over this concept of efficiency might struggle to arrive at. After this, the second bit is if A and B together can complete 80% of the work in 12 days, right? So typically the man day concept, where M1, D1, and W1. M1 stands for the number of men, D1 is the number of days, and W1 is the number of is the amount of work that is done. So 2 men in both cases. In the first case, completing 80% of the work in 12 days. So how much time would they typically take to complete the entire work? Even all of this is not required, in fact. So they would take 15 days. So 2 cancels out. This is 4 is to 5, and 12 fives are 60. 60 by 4 is 50. So basically, using the concept of ratios also, they would take how many days? They would take 15 days to complete the work. Now, this information is used to solve the last leg of the question, which is in how many days can 60% of the work be completed by B and C together? So if you consider the total work, which is 15 days and 8 units per day, how is it 8? Because A plus B is 5 and 3. So therefore, 8 units a day, that would make it 120 units. What is the total number of work in terms of units for B and C in a given day? B and C would be 4 plus 5, 9 units per day. So how much time would they take to complete the entire work? It is 120 by 9 days, right? So if you reduce that further, this is cancelling by 3. So 40 by 3 days is the number of days it takes for BC together to complete the work. How much work will they complete in 60%? So how many days will they take to complete 60% of the work? So it's simple, right? So you multiply 60% is what? 3 by 5. So 3 by 5 into 40 by 3. So 3 cancels. 40 by 5, 8 is the answer to this question.